Hi, I'm Clark on Temptress. Today I'm going to show you how to use one of these to power your laptop in a way that it's inexpensive, it's very convenient, and it'll save you a huge amount of electricity. If you've been living off grid for a while, you know you've got a lot of little devices, DC powered devices, things that use this kind of a deal to power them. And you have to start your inverter to charge them. And I'm sure deep down you go, geez, I've got batteries, they're DC. I want DC. Why do I have to go through AC and back down to DC? Well, in essence, you don't. And today I'm going to show you how to do that in a much more electrically efficient and cost-effective way. I'm going to give you just enough theory to understand why it works, because that usually makes it so much easier. Not going to go deep into it, but we're going to talk about it a bit. The magic thing you need is one of these, and they make all different types. I've got a collection of them here. These are switching power supplies. They've really changed the world a lot when they came out. It's what everything is now. This guy has a switching power supply in it. These do magic. These will actually take the voltage and convert it such that maybe, basically they go to watts. So if we had 10 amps being consumed at 12 volts, that's 120 watts. But if we needed 20 volts coming out, we would have 5 amps and 24 volts, which again is 120 watts, minus a little loss in the system. But they can step up the voltage, or when they step down the voltage, that was probably a better example. If you had 20 volts, 24 volts coming in at 5 amps, you could actually feed 12 volts at 10 amps. This is essentially the circuit that's in the middle of an MPPT charge controller. If you have a solar charge controller, that's at all modern. The heart of it is this. The only thing that's different is I'm going to be adjusting some potentiometers today, and they have a little microprocessor doing that constantly, kind of looking at the sun and running the throttles. So let's get into it just a little bit. How do these work? Not going to go deep into that. There's a bit involved. I've had to design these. There's one of these circuits in the BankManager that takes the very high voltages that come in, which could be as high as 80 volts in some applications, and steps it down to the very constant 5 volts that the microprocessor requires. But they all work the same. This one's just a lot bigger. In comes a DC power supply, current and voltage coming into it. There's a processor in here that will switch the incoming power on and off very, very fast. It's usually switching at about 20 kilohertz. That's 20,000 times a second. It's really, really fast, but microprocessors and transistors, they can do that just fine. So that's why. And why they chose 20 kilohertz is if there is any hum, it will be outside of human hearing, so you won't hear it. You know, if anything got delaminated and starts doing magnetic tricks. So what does it do at that rate? Well, it charges up this. This is a coil. It's just a bunch of wires wrapped around a core to hold the magnetic field a little better. And if you look carefully at this one, you'll see that there's a fair amount of wire. These wires are fairly large, and there's actually 3 of them in parallel wrapping around. So it fires the power through this thing, and it builds up a magnetic field. The magnetic field, when it switches off, is allowed to collapse into the rest of the circuit. And without going into all the math of it, magic happens with coils and collapsing magnetic fields. You kind of get to choose the voltage coming off of them. Same wattage, but you get to choose the voltage. So it watches the outgoing voltage and constantly adjusts the duty cycle. You know, how long was it on for during that 20,000th of a second, and how long was it off for? And it can change that as necessary to move more power through to adjust the voltage coming out of the thing. Well, that's it. That's it for the theory. Now let's get real practical. I've got a bunch of these things. I had, this was the biggest one I had on the boat when, well, actually a viewer wrote and said, hey, can you tell me how I can power my laptop? without going through the inverter? And I said, yeah, sure. And I knew I had one of these. And it turns out this thing will not put out enough power for my laptop. We have monster laptops. We have the kind of laptops that gamers, you know, would really drool over with big GPUs. We need it for the video editing. It's just a requirement of doing this job. Otherwise, it's just impossible to do the high definition video editing we need to do. Either impossible to do it, or the rendering process can take hours and hours and hours. And if you do anything creative, you know that when you put a thought down, you need to see that thought and improve on it. And if you have to wait an hour, you lose your train of thought and everything falls apart. So we've got a monster here. And according to its power supply, it might like to eat as much as 240 watts of power. This power supply, since I've got it up, is a 20-volt power supply that can produce 12 amps. That's a fair amount of power. Anyway, I ordered this, came in from China this week, so I'm going to do the video now. This is a boost power supply, so it can only step the voltage up. It can handle 20 amps, which would be the minimum amount, so that'd be 20 amps coming in this case. And I think it will be perfectly adequate to power this laptop, so we're going to give that a shot. Over the years, I've used hundreds of these things, and I keep them around because they're so handy. This also is a boost-only power supply. I bought it because I thought I would do this project, but it was for an earlier laptop that wasn't quite so hungry. You'll find them like this with displays on them, which makes your life easier, but if you have a meter, you kind of don't need the display. This one is what's called a buck boost converter, so it can both raise the voltage and lower the voltage. That makes that very handy. I believe this one is also a buck boost converter. I'd have to look it up because I haven't used it in a while. I use these, they're very low in the power they can handle, but in our dingy different video, but I've got a little solar panel and I use one of these as a very, very cheap voltage regulator to charge the lead battery that's in the dinghy that runs the bilge pump and the lights and those kind of things. So that's a different video. If you want it, ask for it and I'll tear that apart. In fact, I need to, because while we were away, I think this circuit got wet and flooded, and it lasted 3 years. Anyway, I wasn't taking care of it because we weren't on the boat and it died. So might be good to do a video on that. Back to this guy. So this guy's pretty massive. This guy will provide the power this needs. Let's talk about expense. It's the most expensive one on this table. This one was less than 20 bucks. They're not very expensive. If you were to go shopping and find something that can like plug into a cigarette lighter and it has a little box and then it plugs into your computer, they work fine. But the two problems with that are, first off, you're not going to find one that can do 240 watts. Just aren't. I think I've seen 100-watt ones, and you know, nothing really works to its full rating. It would be frightfully expensive. They're over $100 last I looked, and I haven't looked for a long time because I just build my own now. So let's play with this. I think the right thing to do is we're going to hook it up to a battery, because I've got a big portable battery here, so it's the easiest way for me to get 12 volts onto the table. And then we're going to work with the output section and take a look at it. It needs some calibration. We've got two potentiometers. This one says CV near it. There's no manual that comes with these, by the way. This video will be your manual. And this one says CC. And this stands for constant current. This is constant voltage. And this is how you adjust the voltage that goes into your laptop and becomes available. You don't want to get that out of the range that the laptop will like, or bad things could happen. This has fuses, and of course you'd want a circuit breaker coming into this because you want to protect everything that you can. You're protecting the wires in particular from starting your boat on fire. Well, let's dive into this. We'll get to the laptop later. I'll put that aside. I have this handy dandy battery I built years ago. I use this all the time. Just a quick peek here. Lithium iron phosphate cells, a circuit breaker, so we'll turn it on, and it brings the power out to these terminals. It's in a waterproof box because we use it in Emily's little dinghy with an electric outboard motor, and this pushes this all around for Never ran it down. I mean, we get tired of being out there before this thing goes dead. It's really nice. So let's hook it up to some power. This device strangely has dual input terminals, and that's so they can, get more current without things getting hot. When I hook this up permanently in the boat, I will probably, make more of a custom wire. But for this purposes, I'm not going to run it for terribly long. I'm doing it with spade terminals. So one of those do as I say, not as I do. Anyway, run the real copper here. Like split the wire and run it to each of these terminals. They're labeled here before I hook it up so you can see it. V in positive and V in negative. V in would be voltage coming in. And obviously the positive goes to the positive side and the negative goes to the negative side of the battery. Now, these would be the same wires you'd be hooking right to your ship's main DC bus bars through your switching panel. And you would have this handy place to make power. Okay, let's hook it up to the battery. Make sure I'm doing it right, because I don't think this is reverse voltage protected. So hook up one side. Now, devices like this, just like inverters, they have big capacitors. You can see them right here. And these big capacitors are going to want to charge up really fast. Lithium being lithium, it's going to also attempt to charge them really fast. In short, you're going to see a spark. These aren't that big of capacitors, and this lithium cell and battery is well up to the amps that are going to come out right away. But anyway, here's going to be a little spark. And then once the spark is over and you've charged the capacitors, that's kind of over, and you can hook it up and not much current will flow. And actually, let's do that too, since I have a meter here. See when it's not doing anything and it's just sitting here, how much power it's consuming. This isn't perfectly accurate, but it says, well, 0.01 amps. That's a fair amount, but you don't trust this kind of clamp-on meter down that far. We'd have to use a better meter if we really wanted to know. Okay, so what do we got now? The lights came on. Here it is. Let's hook this up to the voltmeter. Get these out of the way. These say V out, whoops, back to this. V out minus and V out plus. This is where the output of the circuit is. And we're right now just going to hook it up to this multimeter. Put the red on the plus and the black on the minus. Come on. And let's see what it says. We'll set it for DC voltage here. And right now it's in, yep, it is seeing 51.0 volts. That's a pretty high voltage, and we know we don't want to hook it up that high. What is it with screwdrivers? I never can find one when I put it down. Here it is. Okay. So we'll go to this constant voltage potentiometer and just twist it, watching that the display. And you can see it's going down as I turn it. You have to turn it quite a lot. I'm just spinning it right around. I'm down to 40 now. We'll take it down. We know we want 20 volts. So we take this down, down, down. There we go. Dial it in a little. I went a little too far. Okay, 19.99 volts. That sounds like 20 to me. As far as how accurate you need to be, the rule of thumb for electronics is within 10%, you're usually fine. The problem is we don't know what chips they're really using in the laptop. We know the engineer said 20 volts. Does that mean that the chipset was wanting 20 volts and you can go to 22 and you could go down to 18? Or did the chipset really want 19 and you're already at the edge? So I would aim right off. And with these things, it's easy to. That you can see that's not even wavering much. The voltage will never go above that the way this circuit works. But since the wires we're using are fairly small, there will be a voltage drop in the wire, so it'll be lower. Lower is not going to be a problem for the laptop exactly, because the laptop, if it sees lower voltage, it just might find that it can't charge its battery while it's doing its work. They actually operate at much lower than 20 volts internally, like 3 volts or less. So it should be able to operate fine, but it just might have a little trouble charging at full speed. So what I'm trying to get at is, it's not going to be harmed if the voltage goes down. It just might not charge the way you would want it to. Okay, so we've got 20 volts. Took it to the laptop. I've got this wire. Now this is really short, and I've ordered a longer one for our actual use, but this was like a little converter, and I cut off the other plug. And why I bought it was a cheap way for me to verify this is the right barrel to plug into the laptop. I have an Asus laptop, and I wrote it down here. This is a 6mm by 3.7mm connector, barrel connector. And if you look inside, you'll see there's a little tiny pin on the inside of this. Some of these bigger barrel connectors have that. First thing you'd want to do is go to your regular laptop power supply and take a look at what they're putting out and verify you end up getting the polarity right. So this tells me that it's negative on the outside and positive on the inside by looking at the little display, the graphic. And I'm going to verify that because never trust anything. Laptops are expensive. Okay, so I got this set for voltage. I'm going to touch this to the outside. I'm going to slip this onto the inside, and what do I get? I get 20.1 volts, and I do, since I'm using red on the inside, I have a positive number, so it is positive on the inside, negative on the outside. So we want to make sure we do the same with this. Now, you can do continuity testing and check it, but I think I've already verified that in my case, the black wire goes to the outside, but you'll get a double test of that here in a second. So, much like I said before, just hook it up to the outside. I think some of you are probably upset that I'm working with this on, and maybe I should shut it off between tests, but it's hard to do a video that way. Okay, so we go back to our meter and do the exact same test. Touch the black to the outside, and I touch the red to the inside, and what do I get? Just a skosh over 20. It's over the 19 because while I was messing around, I did adjust the voltage again. I just couldn't help but play. So we get our nice 20 volts coming out, and it's not a negative in front. Make very sure that the negative sign here isn't being displayed. Okay, let's move some things around, and now let's see if I make smoke come out of my very important to me laptop. I guess the mystery for you guys is over, because if you're watching this video, and since this is my only laptop on the boat right now, I succeeded, because that means I was able to edit off this laptop. But let's give it a go. So we take our device, we find a little hole here, and we plug it in. Well, no smoke came out. That made me feel good. And if you look at the laptop, you'll see that the little charge light came on. That's good. Let's turn on the laptop and boot it up. It has a battery inside it, of course, so we know it's charging because the little light came on, or at least that it sees power, but we don't really know yet if it's charging its battery. I know the battery's down a little tiny bit in this one, so that's good. So, booted up the computer. It's running off the power supply here. So got a little light here near the keyboard that says orange, which means it's charging the battery, so that's good. And the computer's running, so it's all running off this big battery now. Let's get her started. Put in the secret pin. That That's nice. Emily left me a little picture. Okay, so we're now up and running, and I've started OBS, which is going to do recording the screen, so you'll be able to see the screen better. And let's see, let's put a load on this. I'm going to start our rendering tool. We use DaVinci Resolve. If you have a YouTube channel and you're not using DaVinci Resolve, reconsider your life. This thing is wonderful, and even the free version is wonderful. I highly recommend it. We used other things before, things that cost money, and we're happy we changed, and quite honestly, we paid the money and have the studio version now. It's worth it. It's just so good. Okay, start last week's video, and I'll just re-render it because that puts a big load on the computer. And if it can do that and charge its battery, this can do anything. So we'll go to the preset YouTube and hit the render button and say yeah, and start the render. So this thing is now rendering a video. That is a pretty tremendous job for a computer to do. And we'll bring up the task manager so we can take a look at this. And what we find is 100% CPU usages. Every core is doing what it can do. And the GPU is working pretty hard too, 60%. It's at 75 degrees and going up in temperature because it's working, and all that power is coming out of this battery. Plus, remember, all this time, it's charging the onboard batteries. In fact, we can take a look down here. We can see that we got that little cord icon, so it knows it's plugged in. And it says we're 91% charged. In 14 minutes, we will be fully charged. So this is working like it would work if we were plugged into the mains. It doesn't seem to care very much that we're only plugged into this DC power supply. I guess that's about it. So this is working. I'm going to call this a success if it's not getting hot. And it's not. It's just a little bit warm. Yeah, let me shut this all down and save the OBS, and then we'll discuss the finer points of how to put one together. Well, that was a success. No smoke came out of the computer, and the computer functioned off this. It didn't get too hot, so I think that's good. Things to consider. If yours does get hot, it might need a little help. That doesn't necessarily mean it's a failure, but a little fan goes a long way in cooling things right on the heatsink. This particular unit has a little plug for a fan here, so if you got yourself, since you're plugged into 12 volts, a 12 volt fan with that computer kind of plug and one of those little tiny square fans, I think you'd be very well served with a little extra cooling if you're in the tropics. But this one actually looks like it's going to be just fine without any extra cooling. When I mount it, I'm going to mount it vertically so the air will flow up through the cooling fins. The convection will pump the air a little that way, where if you mount it this way, you can see how the rising of the hot air wouldn't help you, but this would help you. Of course, there'll be a longer cord. This is just what I have now, but I have a longer cord on order. If you absolutely want to do this project, but you just can't find the cord you need anywhere, and some of these computer cords are difficult to find, the plugs, you could always do this. You could take your power supply and cut the cord, and then put good plugs on it so you can plug it back together, and put a cord on this, do the same. So you can actually take this end of the cord and move it over to the DC device when you want to, but still put it back onto the AC device if you're going to take an inland trip or go to a hotel or something on that order. Now let's talk about acquiring one. Let's say that all makes sense. You go, yeah, I can do that, Clark. I want to do that. How do I find one? Well, there are so many boards that do so many things on eBay that are really reasonably priced. This is one of many. But to find them, you've got to know the magic words. And the magic words for these are buck converter, if you want the voltage to go down, boost converter, if you want the voltage to go up, which this is. There's also something called a buck boost converter, which is very, very handy because it will basically handle any voltage, one above your source voltage or one below, and anywhere in between. You have to make sure that the device is rated to handle the number of amps your your appliance is going to try to pull down. This device wants 12 amps at the max, though we never saw it draw that many. And this guy's rated for 20, so plenty for laptops, probably any laptop you'd ever find. But other things would be different. Let's say, for example, you didn't want to do a laptop. You wanted to do something that ran off 12 volts. Well, there's a lot of these kind of devices around. Here's a power supply for something that needs 1 amp, 1000 milliamps of 12 volts, but 12.0, 12 volts, not nominal 12 volts. You know that your battery, like when the engine's running, could be 14.6, or it can go down to 11s overnight if you have lead only. So if you got yourself a buck boost converter that was big enough to handle several of these 12 volt powered devices, it might be handy to have that installed and dial it right in for 12, and then you have a couple wires coming off it. They'll put off nice regulated 12 volts. I have things, for example, my external computer monitor that wants 12 volts. I run it off something like this, but one dialed for 12 volts. Works out great, and I have remote hard drives and a NAS and all of those things in another room that require 12 volts. I do much the same thing. Anyway, now you've been introduced to the world of buck boost converters, to switching power supplies, and I hope I've taken away some of the mystery, and you see that they're just something that you could take advantage of and solve your problems in power. Hope you enjoyed the video. I'm Clark on Temptress, and have a good day.